we'll get started. If you have not responded to the online poll, please go ahead and do so. Just a couple things. I have posted an old midterm exam. Okay, so we have our midterm exam on Friday. It's going to be closed notes. Use your brain. Okay. Only I'll cover regular expressions today, and Friday's exam will cover up through today's material. Okay, so everything from day 1 up through today is might make an appearance on the exam. Wednesday I'll cover other stuff that you do not have to worry about Wednesday's material. Okay? Yes, question. Yes, it's going to be right here, and then you can expect on Thursday evening I will send out a seating chart. Okay, so I'll send out a seating chart for the exam. I've started using a seating chart because a few quarters back there was an incident, and I think the incident could have easily been avoided with a seating chart. So. So I'll send that out, okay? If you're left-handed, you can either send me an email, or basically when I send out the seating chart, I leave the left-handed seats open, and then if you're left-handed, you can move to the left-handed seat in your row. But pretty much, it's pretty straightforward. You can expect to see one show up in your inbox somewhere around Thursday evening, okay? Any other questions about the exam? All right, and it's going to be a similar format to the previous one, just all different, right? So, okay. All right, so today we're going to talk text processing and regular expressions. This is not specific to R. It's just a general programming concept that appears in many languages, but it's incredibly powerful. It's incredibly useful, and I think it's worth at least spending one full lecture on the topic, okay? So we are going to cover regular expressions with the package stringr, okay? Stringr, and so before I get started, just a couple things. There's a cheat sheet on regular expressions. This is just a general regular expressions cheat sheet, not something specific to R. And if I do include regular expressions on the midterm exam, which I probably will, I'll include this one cheat sheet, okay? But no other cheat sheets or anything else is allowed, okay? And this will just be included with the exam. Stringr is written by Hadley Wickham, author of the Tidyverse, and he wrote a vignette on its usage. And then a lot of times when you want to just test out a regular expression, there's different tools. I mean, you can use like Notepad++ and Emacs and things like that. But this is a great site to use to test in your browser, okay? And then again, there's a bunch of different varieties and flavors of regex, okay? They're all pretty. A lot of things are standard and common, but some of these things vary slightly from system to system. We're using just plain old ASCII ICU regex, okay? Okay, so anyway, if you want this stuff to work, let me zoom in here. Load up package stringr, okay? So install.packages stringr, library stringr. You can look up the help there, okay? What's going on here? Okay. All right. These are just some of the functions. Detect will return true or false. Locate will return a value, a number, telling you the position of the thing. Probably the ones you're going to be using the most will be extract and match. Okay, extract will be extract the corresponding text that matches a certain pattern, and match will tell you if there's a match, or will pull out the matching groups. Okay, and then split will split strings into pieces. Okay, there's a little comic on regular expressions from XKCD, and I thought it was kind of cute. I don't know if you guys can read it. It says, whenever I learn a new skill, I concoct elaborate fantasy scenarios where it lets me save the day. And it says, oh no, the killer must have followed her on vacation. But to find them, we'd have to search through 200 megabytes of emails looking for something formatted like an address. It's hopeless. And then our hero runs in. It says, everybody stand back, I know regular expressions. Types a few things on the computer. And indeed saves the day, okay? And this is an unlikely scenario, but regular expressions do allow you to do something somewhat heroic in this fashion, okay? All right, so we'll just start off, and the first thing that you can do for regular expressions is just do a search, right? So this is much like, so you know, if you've ever done on Word while you're writing a document, you might do like find or find and replace, okay? And sometimes when you're doing, the basic feature is like the find and replace feature on Word, okay? Or just find. You can just say, can you find anytime I've used the word California? Or anytime, you know, so here we've just saying, I've got a vector of words, and we can just say, you know, search for this, and it's gonna find it in the very first element in this vector. If I say search for is, it's gonna find it in this and is, okay? Because is appears in this and is appears there, so it's going to say there. And then if I say or, it appears in vector and also in words. Okay, yes, question?
Is it case sensitive?
It is case sensitive, okay? It is very much case sensitive. Okay, but if there might have been a time where in Word you didn't want to find the exact thing that you're looking for, but you were like, man, I wish I could find anytime I've used, you know, like for California, I want to search for both CA and California, and some people might call our state Cali, but you know, they are not obviously from California when they say that. So, but you might want to search for, you know, instances of such a thing, but you know, you don't want to just search for CA, okay? Because CA could match a whole bunch of other things. So you want to either search for, you know, capital C, capital A, or, you know, things like that. And something like that might be difficult to do in Word. You'd have to run like multiple searches, but we have something called meta characters in regular expressions that allow us to do multiple options and things like that. And so these things, the dot, I don't know, caret, $, star, plus, question, and all these braces count as meta characters. And so if you wanted to match a literal, like if you wanted to search for this actual square brace in a string, you have to tell it, you have to use the slash to say, I'm not using the meta character, but I'm using the literal thing. The only unfortunate thing is in R, slash is a meta character itself, so you have to use the double slash, okay? In other regex things, a single slash is fine, but in R we have to do a double backslash, okay? All right, but this is how the meta characters get used. So when you use do something like a backslash capital A or backslash cap Z, or backslash little b or backslash big B, these indicate boundaries, okay? Also caret or $. So this is either start of string, end of string, or a word boundary or a not word boundary, and I'll explain all of these in examples here, okay? So this means, you know, when you're searching for some kind of string of characters, this will say only identify a match if it's at the start or the end of the string or at a word boundary, okay? So here I've got our string. It's not a vector anymore. It's just, well, it is a vector of length 1, okay? It's the quick brown fox jumps over the lazy dog, okay? And I purposely put a dog there twice, okay? And so here if I say replace all, anytime you find the instance the, it's going to replace the with the dash here, and it replaces this the and this the. The and the quick brown fox jumps over the lazy dog, it replaces them both, okay? But here I've modified the search to say caret the, okay? And this means it's only going to match the instance the if it's at the start of the string. So it matches this the, but not the one down here where it says the lazy dog, because this is not at the start of the string, okay? Similarly, what happened here? Okay, similar for identical is to the caret is the double backslash A, caps A, okay? And that's these two are identical, okay? So they both perform the same thing. So you might see one using a caret or the capital A to say at the beginning of the string. And then here I've got the $, which means the has to appear at the end of the string, and there's no match there, okay? There's no match because we have the word the, but neither of them appear at the end of the string, so it doesn't match anything, nothing gets replaced, right? Okay, over here I've got dog, so if I just do dog, it will replace both instances of dog here. And if I say dog $, it only replaces the one at the end of the string, okay? Question?
How would we be able to replace the dog that's like one before the last one and keep the one that's the last one?
So you want this dog, but not this one. Okay, so you'd have to say, I guess you can do dog space, replace with a space dash. That's or replace with a dash space. That's probably the easiest. There's probably another way, but that could work. Okay. All right. Here I've got our text string says words, jump, jumping, umpire, pump, umpteenth, and lumps. Okay. And if I say replace all instances of UMP with a dash, it replaces in jump, it replaces the UMP here, UMP in umpire, UMP in pump, UMP in teenth, and UMP in lumps. Okay, it replaces all of those. Okay, and now I'm going to show you how the word boundaries work. So this says the little b / little b is a word boundary, okay? Which means it's only going to replace those where ump is preceded by a word boundary. So a word boundary is either a space coming before it, okay, but it's not the actual space. The space is a space. It's just if there is a space in front of it, then that sees it as a word boundary, okay? And then, or if it's at the start of a string, that will also count as a word boundary, or the end of a string counts as a word boundary, okay? So here, word boundary UMP will only replace words that basically start with ump. So it's going to replace the ump in umpire and umpteenth. Okay, here I say non-word boundary, capital B. So a lot of the things in regular expressions will have the little lowercase letter for that thing and the capital letter for not that thing. Okay, so little b will be for word boundary, capital B for not a word boundary. Okay, so here we want not a word boundary, bump. Okay, or not a word boundary, and then followed by UMP. So this means it will replace the UMP where it's not preceded by a word boundary, okay? So it'll replace the ump and jump and jumping and pump and lumps, but not in umpteenth or umpire, okay? And here it means ump followed by a word boundary. So it will replace the ump in jump and pump. And then here it says replace the, for ump followed by non-word boundary, okay? So jump gets left, but jumping, the UMP in jumping is not followed by a word boundary. Same with umpire and umpteenth and lumps, okay? So these are examples of word boundaries and non-word boundaries. Does that make sense? What's going on there? Okay. We have character classes, okay? So you got little s for a white space character, so that's going to be things like so that includes basically spaces and tabs and things like that. And it includes both breaking and non-breaking spaces, okay? Are you guys familiar with non-breaking spaces? No? Okay, here, let me just give you an example. So so when you write a document in Word or something, okay, let me just go ahead and like, I live in the city of Los Angeles, okay? So this is here, and as you write, you can say hello. So when I write hello, Word will say, oh, you've reached the end of the line here. Angeles doesn't fit, so I'm going to push, it moves the entire word down, right? So as soon as I put in the H there, it pushes Angeles down, okay? So that's because the space, there's a space between Los and Angeles, okay? However, you might say like, Los Angeles, that is a proper thing, and it's improper to separate the Los from the Angeles, right? And so in Word, you have the option. So all spaces look like, if you turn on the symbols character, you can see this. You can create something called a non-breaking space, okay? You Command Shift space or Control Shift space, okay? And so here, this space, which is different from this breaking space, will force Los Angeles to stay together, okay? So it says, I live in the city of Los Angeles. As soon as I type the H here, when it won't fit, it pushes both Los and Angeles together. It's almost as if it sees it like an underscore, where it's going to keep it together, okay? But it appears as a space, okay? And this is an issue that appears in when you do the baseball reference thing. One of the things is things like Arizona Diamondbacks. The space there is a non-breaking space. It says we've got to keep Arizona with Diamondbacks. It's basically like an underscore that's invisible, okay? And it creates problems. So there's a part that I say text cleanup, and that goes through and it replaces all of the non-breaking spaces with breaking spaces, okay? But you know, when you look at stuff, you can't tell, right? It's only if you turn on hidden symbols preview that you can see stuff like that. Okay, well anyway, so that counts as white space, and then again, capital S will be non-white space, little d for digit, capital D for non-digit, little w for a word character. A word character is basically all the ASCII letters, A through Z, caps or little caps, and then all the digits 0 through 9, or an underscore character. These all count as word characters, okay? And capital W will be non-word character. And then the dot is kind of the wild card, and it's basically for any character, okay? Dot will be everything. Okay, and then we have quantifiers. Quantifiers will basically say, I want 0 or more of these things. That's a star, and this is what we call greedy. And then the plus is 1 or more, and it's also greedy. The question mark means 0 or 1. And then curly brace will mean I want exactly 3. Curly brace with a number and nothing followed will be 3 or more. And then curly brace 3, 5 will be 3, 4, or 5, okay, up through a range, okay? So you can say I want to find digits followed by this curly brace 3, and it will say I want to find exactly 3 digits. I don't want 2 digits, I don't want 4 digits, I want exactly 3 digits in a row, okay? Something like that, okay? You know, a digit with a plus, a /d, /little d with a plus will be I want 1 or more digits. So we'll do like 1, 2, 3, or 10 digits or 100 digits, as long as they are all continuous digits, okay? So these, you can combine these and you can start creating some pretty impressive patterns, okay? So here, I've got just this text thing that says words or numbers. I've got 9,876 and combos 1, 2, 3 as one word, and then password underscore 1, 2, 3, 4 here, okay? This is a bad password, by the way. Here we're gonna say replace all space characters with a dash, okay? And this looks exactly like the thing above, except all the spaces have been replaced with dashes, okay? Here, I say replace everything that's not a space with a dash, and it looks like this, okay? And then here I say everything not a space with a plus. This means 1 or more space characters. So basically, everything here where it says words got replaced with dash, 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 it's going to see this all as one continuous match, okay? So all of this gets one continuous match, so this whole thing for words gets replaced with a single dash. And then the word or, it sees that as a continuous match, and that gets replaced with a dash and things like that, okay? So anything that's not a space and it's continuous will get replaced with a dash, okay? So this basically has turned this whole thing into dash space, dash space, dash space, okay? That is different from word character. So here I've got non-space, 1 or more non-space, and this is one or more continuous word character, okay? And the only difference here is that the comma is not a word character, so the comma gets preserved, okay? The 9 gets replaced with a dash, and the 876 gets replaced with a dash, but the comma does not, okay? Whereas over here, the comma is not a space character, so it gets included. And if we count these, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 dashes here, 1, 2, 3, 4, 5, 6, 7, 8. And if I count these, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 because the comma separates one set of word characters from another. Okay. If we keep working on these things, here I say replace all of the digits with a dash, okay? And so it replaces everything with a digit with a dash. And here it says replace everything that's not a digit with a dash, so it replaces all of those, and so the comma gets replaced there. And this says replace all continuous digit characters, so D plus is 1 or more, and so the 9 gets replaced and the 876 gets replaced with a single dash because it sees that as a match, a continuous match for /D plus, okay? And then 1, 2, 3 in combos 1, 2, 3 gets replaced, and then the 1, 2, 3, 4 and password underscore 1, 2, 3, 4 also gets replaced, okay? And then over here it says replace everything that's not a digit character, so that's going to include letters and spaces and commas and things like that, and we basically just get this all boiled down to just that, okay? And here's just some examples of word characters, okay? So this is replace all word characters, and we get all of this. Again, the spaces are untouched and the comma is untouched, but basically everything else is considered a word character. Non-word characters, so that would be the spaces and commas, get replaced with dashes. And here I say word character plus. We've already seen this already, but just to kind of highlight the difference between word character and non-space character. And so because they're continuous, they get replaced there, and then this will be replace this thing, and this thing ends up being identical because we don't have any, I didn't put any places where there were 2 spaces, okay? I have something here. I put the question mark, okay? The question mark means 0 or 1, okay? So as it goes through, it's going to look for anything where there's a match of 0 or 1 and replace that with a dash. So it technically matches that there are 0 digits before the T, okay? So it replaces that with a dash. And it says there's 0 digits between the T and the H, so it replaces that with a dash, okay? And it keeps going, and it says, okay, there's 0 digits after the year, okay, and replaces that with a dash. And so you get this weird thing, okay? So the 0 or 1, it's searching for every possible match, and it's going to say, okay, well, I found 0, and we'll replace the 0 match with a dash, okay? I know that feels weird, but that's how this thing is operating here. Here it says I want to find exactly three digits in a row, okay? So what it's going to do is it starts and it finds the 199 in 1996, and it will just replace that, okay? And then it has a 6, and it says, well, that doesn't match 3 digits, so it leaves the 6, okay? The 310 here gets replaced, the combo 123 gets replaced, the password 1234, the 123 gets replaced, and here single digit 5 doesn't get replaced, okay, because that doesn't match. And here it says match anything between 2 and 4 characters, so the 1996 will match because there's 4-digit characters, and all of those get matched up as well. Okay, so you can combine these meta characters or these character classes along with quantifiers and start matching things like this. All right. Here we have square braces, okay, square brackets, and you can specify a range of characters. So here I've got square brace A, E, I, O, U, which means replace basically the vowels, okay? And it will say replace one of. So this is not the words, it's just one character, A, E, I, or U, okay? So one of A, or E, or I, or O, or U, okay? And this, when you put the caret in there, it says basically anything but these letters, okay? A through Q will do lowercase letters A through Q. Capital A through Q will be all uppercases A through Q. And if you want all 26 ASCII letters, you can specify a character class like little a to Z and capital A to Z, okay? And this is how you match all 26 letters, because this /W is for word, but that includes digits and underscores. And if you only want letters, you got to do this, okay? And if you're working on things that are not English with like foreign letters and things like that, you got to look that up, okay? On how the Unicode and the regex are specified, okay? And then again, you can specify digits, a range of digits. So here's like 0 through 7. But if you want all digits 0 through 9, just /D is going to work just fine. Okay, so here again, I've got the year 1996, area code 310, combo 123, password _1234, single digit 5. And so if I search for pattern with bracket YEAR, okay, string extract will only pull out the first thing that matches, which it will come along and it'll go T, that doesn't match, H doesn't match, E. Oh, that matches right here, okay? And it will pull out the E, and there you go, okay? Here for string replace all, everything in this pattern of year, it's going to replace any instance it finds a character that matches Y or E or A or R with a dash. So here it replaces the dash, the E and dash, the E and the, and it replaces all letters here. Y with a dash, Y matches 1, E matches, A matches, R matches, okay? Area, all letters in area match YEAR, okay? And then the E in code, and then the A in password, and R, and things like that, okay? So they all get replaced with dashes. All right, here it says, find anything that matches YEAR, one or more of these things, okay? And that will replace the, and then what year is it counts as an entire match, and so that gets replaced with the dash. In area, all 4 characters counts as an entire match, because all 4 characters count as one or more of these letters Y, E, A, or R, and that gets matched. You know, probably an even better example. All right, so here, let me get the same text. And then so if you say, well, I don't want to replace the E in the, let me, okay, so then you can specify like 2 or more, okay? So here we're going to say, you know, we're annoyed that the E in the gets replaced and the E in code and things like that. So you can specify, I want year, but not year, but the letters Y, E, A, or R, and I need 2 or more before I start replacing them with dashes, okay? And so what will this replace? Year and area. Okay, so when I run those, it will just replace year and area, because these are the only things that match with 2 or more of these things, okay? Okay. Here we have, I don't know if I'm doing this way too fast. You have time to kind of review the notes, okay? There's a lot to cover, but because there's a lot you can do with regular expressions, all right? And you'll get like just a small taste of it when you have to write your own regular expression for extracting that one column of manager names in your homework, okay? Okay, so here you can use parentheses, and these are will create groups, okay? And so so you can say I want match the text basically A, B, C, D, and it will extract out a group of anything in the parentheses. So it will capture the text B, C. This is just a literal matching of A, B, C, D, and you can say this, okay? And here, if you put a question mark colon, this will say, here's a group that I want to like match with, but I don't want to actually capture this. And I'll explain the difference between capturing and non-capturing groups, okay? You know, we're doing just a literal match, okay? And again, just the things with parentheses will form groups. And then, and if you want like some kind of or operator, this or this or this, you've got to use the vertical bar, okay? So, and preference is given in the order, So it's going to prefer to match the Mrs. before the Ms. before the Mr., okay? And then if you've used groups, and you're going to use something like string replace, /1 and /2 will make reference to the first group that was captured or the second group that was captured, okay? All of this stuff, I'll show you the examples. I think it'll make a little bit more sense here, okay? Okay, so here, I've got this text that says Mr.Smith, Mrs.Lee, Ms.Garcia, okay? Or a comma in between these things, okay? And so here we are going to try to match the MRS or the MS or the MR, okay? And so what it does is we said match all, and it finds 3 instances where this pattern is matched, okay? And then when you do a match all, it will pull out it'll pull out the pattern that matches, and then it will also say it will extract out the group. Because the entire pattern is the group, the 2 columns end up being the same, okay? But here it's going to say, okay, I found Mr. and Mrs. and I found Ms, okay? Or MR, MRS, and MS. Over here, it's the same, almost the same as before, but here because the MR is listed before the MRS, it will match the MR first and give preference to it, okay? So here, the results are almost the same, except in line 2, when it comes across MRS.Lee, it's gonna find the MR match first, give preference to it, and say, aha, I found a match, and extract that out, okay? So that could be an issue. This is basically equivalent. This says find an M, and then the R question mark says 0 or 1 R's, followed by 0 or 1 S's, okay? So that will match, so it will technically match just M all by itself, and it will also match MR or MRS or MS, okay? So this will, the only issue with this is it will match M all by itself, okay? But it pulls these out, okay? Mr. MR, MRS, and MS, okay? So this pattern there. Okay, here I have this where we've got this, and I say, okay, this is what I want you to match. The MRS, MS, or MR, okay? And then /dot, which is find the literal period, okay? The literal period. The dot normally is any character, but here I want the literal dot, okay, which is what we have, followed by a space, so we have to match a space, followed by a, 1 or more word characters, okay? The MRS, MS, and MR are in parentheses, so that counts as a capture group, and then the word characters, 1 or more word characters, is also in parentheses, and that counts as a capture group, okay? So here it's gonna say, and we say match all, so within this string, it finds a match, Mr.Smith counts as a full match, okay? And it's gonna extract out the capture groups, which are MR and Smith, okay? So this matches this capture group and this matches this capture group. We have Mrs. Lee, and it pulls, this is the full match of the pattern, and it pulls out the capture groups. And here we have Ms. Garcia, and this is the full match of the pattern, and it extracts out the capture groups. Is that okay? All right, so here, if I switch my capture, my pattern to say, to become, to use this question mark colon, okay, it's gonna treat this the same as to group these letters together, the MR versus the MRS versus the MS and things like that. It's gonna group those together, which we need to handle the OR operator, but we say, I am not interested in capturing this, okay? I'm not interested in trying to find this, this thing, okay? So basically, I wanna find things that look like names, Mr. Smith, but I'm not interested in capturing this out, so what it returns is it just pulls out the Smith, the Lee, and the Garcia, okay? And yes?
So if you had comma Smith Road, it wouldn't pull out Smith from Smith Road?
Right, here, so if we have, where did it go? Okay, comma, Smith Road, okay? And we run this, because Smith Road does not match this capture group, okay? This doesn't count as a match, okay? So it completely ignores this because it doesn't match it as a capture group. Okay, so it does the same. Okay, so that's kind of that works. Okay, here is an example of referencing the capture groups themselves. Okay, so here I've got George Washington, John Adams, and Thomas Jefferson, and here I say match two words separated by a space and maybe a comma. Okay, all right. So maybe I'll also throw in string, whoops, just so you can kind of see what it's doing. We'll do a string match all. Okay, so here it's going to find the thing, and it's going to find George Washington, comma, okay, because this is the pattern, just word characters, space, word characters, okay? So it's going to say George Washington, followed by a comma, maybe, with a question mark, okay? The question mark says maybe this thing will make an appearance, and in this case it's the comma, okay? Because we've got George Washington, John Adams, and Thomas Jefferson. There's no comma after Thomas Jefferson. If I didn't put this comma here, it will not match Thomas Jefferson because Thomas Jefferson is not followed by a comma. So I need to put the comma in there. So, okay, so here we've got this, and so it pulls out George and it pulls out Washington, and this will be the first character group, and this is the second character group. Now here, if I say replace this text with this pattern, which is going to be the second matching group, comma, the first matching group, followed by a semicolon, it will write this: Washington, comma, George, semicolon, Adams, comma, John, semicolon, Jefferson, comma, Thomas, semicolon. Okay? And so you can take some kind of string like this, use capture groups, and then reference them in some kind of replacement thing. Okay, is that all right? Using this, so this is really, it's really powerful stuff. Okay, just a couple examples. So I've got the letters A through Z, and here I say B, one or more word characters up to I, okay? And so this pulls out, it's going to match everything from B through I, and then because only the word characters are in the parentheses, it extracts out just C through H, C, D, E, F, G, H, okay? Here I've got A, one or more word characters, and then the second group says I want E with one or more characters from A through H. Okay, and so here the entire match will count as A through H. The word character, it's going to try to find as many characters as it can. So it goes from, it will match B through B, C, and D here. And then it says, well, and then the next thing has to start with an E. Okay, so it's going to start with an E and then one or more characters from A through H. And so it doesn't find any A through E, but it finds F, G, and H. Those count. And it stops there. Okay, and so you can start crafting in your head. You can start crafting patterns that might work. Okay. There's an issue called greedy and ungreedy. So basically, the star and the plus are greedy. Okay, if they can, and technically the question mark, but the question mark only does 0 or 1. So here I've got Peter Piper picked a peck of pickled peppers, okay? And we say, well, I want capital P and any characters dot star through R, okay? And so when we do this, it's greedy and it's gonna try to find the first instance of the capital P that it matches, and the dot will match spaces or letter characters or anything, really. It will match anything, and so it's gonna match as much as it can and end with an R. So it picks basically everything up to this last R in peppers, okay? And it ends here. It doesn't get the S, okay? Because S doesn't match the pattern. So this matches what we have here, okay? If I change it to ungreedy, you just add the little question mark after the star, okay? So the only difference between this thing and this thing is that there's a question mark. I can't highlight it, but there's a question mark after the star here, okay? And so here it will say, basically try to find the smallest thing that will match this, an ungreedy version. And so it's gonna find the capital P and the R in Peter, and it's gonna say, I found a match, and it stops there. Okay. I guess I could also do that's string extract, and then I'll do string extract all. Okay, and so string extract all will find everything that matches this. Okay, and then and here I can do this, and what will this match?
Pepper.
Yeah, it'll match Peter, Piper, and Pepper, I think. Oh, picked a peck of pickled pepper. Okay. Yeah, I guess. Yeah, it reads left to right. So it's going to do Peter and Piper, and then starting with picked, it reads left to right. So it's going to start here with this P, and this technically matches as well. So, so I'm sorry, it's not the shortest. It's a left to right and stop when you find something that closes off the match. Okay, I've got a few more examples here that I'll let you kind of explore. I did just want to show you like a use of this where to just kind of demo how strong this stuff is. Okay, so the UCLA website has a directory page, okay, but it's like old school, and it uses PHP, which is which had its heyday like 12 years ago, okay? But anyway, I might come along and I say, I want to search for the statistics department, and it lists off this information, and you can click these things and it brings up this little box that says department statistics, department address. So there's all of this information and you can click all of these things. And here's the information for the administration. Here's the information for the department chair and things like that. But it's not in this form that's conducive. You can try using, what was that? Selector gadget, and selector gadget has issues with this page, okay? So you might do something like view page source, okay? And you can come along and all of the information is actually in there in these HTML things, okay? So it's got, the department, statistics, department address, 8125 math sciences, and things like that, okay? And so what I've done is I've copied and pasted. I just highlighted this underlying text and I put it into just a text document, okay? But we can see it's going to be a huge pain in the butt to try to extract this information, right? So what I've done is I crafted a regular expression that's going to work through us. And I don't know if I have time to explain every little bit of our regular expression, okay? But basically, I've said, find this thing that says label, and then pull out anything that's in there, okay? And then, and along with these things, these are capture groups that I don't want, okay? And I put a question mark because it may or may not appear in there, right? So if we look at something like this, are you guys able to see this? So we've got things like, I want to pull out the thing that says department that's within these brackets that say label, but then if we look at the span over here, we have different tags that appear. There's a B, some of these things have a no BR tag, which we want to kind of ignore and things like that. And so, so I've written up a capture group, and I say, go ahead and match these things and pull out the pattern. And then pull this out. And this is basically all I've done is just used some regular expressions here, okay? And here the intermediate stuff is bad, but then I just say, all right, I don't know what happened. I promise it worked earlier. Let me just reknit my file here. Okay, I don't know. But, oh, this is the issue. I have to say new slide. Okay. So, okay, and then so I just run a few regular expressions and I've managed to pull out basically all of the information that's embedded in that text, okay? So this is just the head, but we can see that it's basically processed through all of this HTML tag and information just by kind of matching these tags and expressing the things that you want and don't want, and it pulls that out. And so regular expressions are really powerful, and I think they're great. So anyway, that's the content for today. So we'll see you guys on Wednesday.